Section 2.3, the remainder and factor theorems. Example 1, use long division to factor polynomials. Factor this polynomial completely using long division if x minus 3 is a factor. So we put x minus 3 on the outside, and we put the polynomial on the inside. 6x to the third minus 25x squared plus 18x plus 9. And we ask ourselves, what do we multiply times x to get 6x to the third? We multiply by 6x squared. So we have 6x to the third, and then we take 6x squared times negative 3 as well. So we get negative 18x squared. Now when we do long division, we always subtract. Negative 25 minus negative 18 is negative 7. And then we bring down the 18x. Now what do we take times x to get negative 7x squared? Well, minus 7x. We get negative 7x squared and then plus 21x. And in long division, again, we always subtract. 18 minus 21 is negative 3. And then we bring down the 9. Well, what do we take times x up here to get negative x to the third? Well, minus 3. So we have negative 3x plus 9. And then when we subtract, we get 0. Well, we were told that x minus 3 is a factor, so we knew that in the end the remainder would be 0. Now we just have to factor what's left over. So we need a minus 7 in the middle. How about we go 3x and 2x? That gets us the negative 6x squared. And how about minus 3 here and plus 1? And we're trying to factor this completely. So now we have x minus 3, that's the given factor, and now this polynomial is factored completely. Example 2, long division with non-zero remainder. Divide 9x to the third minus x minus 3 by 3x plus 2. We're going to divide 3x plus 2 into, we have 9x to the third, watch this, plus 0 x squared minus x minus 3. We need to represent all the powers from starting with the highest all the way down. So 3, 2, 1, and 0. But we don't have an x squared. So we'll put it in as a 0x squared. Well, we multiply 3x times 3x squared to get 9x to the third. And then 3x squared times 2 is 6x squared. We always minus in long division, that's negative 6x squared. We'll bring down the minus x. We need to multiply by negative 2x to get negative 6x squared. And then we have minus 4x. We always subtract. That's 3x minus 3. Well, we multiply 3x times 1 to get 3x. We have plus 1. So we have 3x plus 2. And then when we subtract, we get negative 5. So the answer is 3x squared minus 2x plus 1, and then minus 5 over 3x plus 2. Example 3, division by polynomial of degree 2 or higher. We're going to divide x squared minus 2x plus 7 into this polynomial, 2x to the fourth minus 4x to the third plus 13x squared plus 3x minus 11, and none of the powers starting with 4 are missing. So we don't need zeros anywhere here. What do we multiply times x squared to get 2x to the fourth? 2x squared. So we have 2x to the fourth, and then we distribute the 2x squared through. That'll be minus 4x to the third plus 14x squared when we distribute. In long division, we always minus. So we get a 0 here, a 0 here, and negative x squared there. And we're taking these 3 at a time, so let's bring down 2 more. What do you multiply times x squared to get negative x squared? Well, negative 1. So negative x squared plus 2x minus 7 is what you get when you distribute that negative 1 through. And we always minus. And 3 minus 2 is 1, and negative 11 minus negative 7 is negative 4. So the answer is 2x squared minus 1 plus x minus 4 over x squared minus 2x plus 7. Example 4, synthetic division. Divide using synthetic division. If we're going to divide by x plus 2, we're going to put negative 2 in the box. and then we write the coefficients, and we got to account for all of the powers starting with 4. So the coefficient for x to the 4th is 2, but we don't have an x to the 3rd, so we must write a 0. You have to write a 0 there. So we have the 4, the 3, the 2 is -5, meaning the squared is -5. That's the coefficient. Then we have 5, and then -2. For synthetic division, we bring the first number straight down. Then we multiply. -2 times 2 is -4. And then we always add down. So 0 plus -4 is -4. So it's always multiply, then add. So -2 times -4 is 8. -5 plus 8 is 3. -2 times 3 is -6. 5 plus -6 is -1. And then -2 times -1 is +2. So this one has a remainder of 0. Now how do we write the answer? Well, this is the constant. -1's a constant. This is the coefficient for x. This one's for x squared. And the 2 is for x to the 3rd. So answer is 2x to the 3rd minus 4x squared plus 3x minus 1 with a remainder of 0. So we don't really write anything for that remainder. Now when we divide by 2x minus 3, it's like this. We have 10x to the 3rd minus 13x squared plus 5x minus 14. And we're dividing by 2x minus 3. Now we want to do this with synthetic division. So like over here on A, we need a number to put in the box. And the number that we put in the box is as if we're solving this for 0. It's 2x minus 3 equals 0. So we add 3 and divide by 2. So we're putting 3 halves in the box here. But in order to get this to be 3 halves, we have to multiply the top and the bottom by 1/2. If you distribute a 1/2 through here, you get that x minus 3 halves. So then 3 halves goes in the box there. But you have to do the same thing to the top. You have to multiply the top by 1/2. So you get 10 divided by 2 is 5. 13 divided by 2 is just, well, -13 halves. 5 divided by 2 is 5 halves. And then -14 divided by 2 is going to be -7 here on the end. Now you just proceed as usual. We bring the 5 down. 5 times 3 halves is 15 halves. That gives you 2 halves, which is 1. Then we multiply and get 3 halves. 5 halves plus 3 halves is 8 halves, which happens to be 4. And then 4 times 3 halves is, well, it's 6. And then when we add, we get -1. So the answer is 5x squared plus x plus 4 minus 1 over. It really is now x minus 3 halves. Well, we don't leave it like that because really that denominator needs to be 2x plus 3. Well, to get 2x plus 3, we have to multiply the top and bottom by 2. So now the final answer is 5x squared plus x plus 4 minus 2 over 2x minus 3. Example 6, use the factor theorem. Use the factor theorem to determine if the binomials given are factors of f of x. Use the binomials that are factors to write a factored form of f of x. Well, we're going to decide, is x minus 1 a factor of this polynomial? And we can do that synthetically by plugging 1 into the box. We need to write the coefficients. And we need to make sure that all powers are accounted for. 4, 3, 2, 1, 0. Yep, they're all accounted for. So we can proceed. We bring the 4 down. Multiply 1 times 4 is 4. That's 25. 25 times 1 is 25. Add, that's 50. Not looking too promising, is it? 1 times 50 is 50. That's 45. 1 times 45 is 45. So the remainder is a 48. So the answer here is no. That is not a factor because the remainder is not 0. The remainder is 48. Let's plug in -3. 4, 21, 25, -5, 3. See if we get a remainder of 0 here. Bring the 4 down. That's -12. This is 9. So that's -27. This is -2. -3 times -2 is 6. That's 1. -3 times 1 is -3. So that's going to be 0. So a factored form could be x plus 3 times 4x to the 3rd plus 9x squared minus 2x plus 1.